Hello, everyone. We're going to try and start solving this past paper question. We have an ATP paper that's coming up on the 1st of October, and we'll try to solve as many past paper questions in these live sessions that are going to go live on YouTube now. From now on, this one over here is. Hello, everyone. We're going to try and start solving this past paper question. We have an ATP paper that's coming up on the. Okay, so we have this past paper over here, which is May June 2009, and we're going to try and complete this past paper in this particular class. So we're going to start, and it's an ATP paper. Remember, it's related to uh, the experimental part of chemistry. ATP, it's an alternate to practical. So uh, we'll we'll start with the first question, which is a student did the following experiment to find the formula of magnesium oxide, and a 10 centimeter length of magnesium ribbon was loosely coiled and placed in previously weighed crucible, which was then reweighed. So we have magnesium. So we're dealing with magnesium over here. And what the data that's given is the mass of the crucible plus magnesium is provided, and the mass of the crucible is also provided. So you're being asked the first part, the simplest part is calculate the mass of magnesium. So you would need a calculator for this. So let's open a calculator, and it's going to be 13.08, which is this one over here, minus 12.72. So 13.08 minus 12.72 gives me 0.36 grams. That's the very first part of the question. Let's move to the next part of the question, which is then a crucible was placed on a pipe clay triangle and heated strongly for several minutes. So he's basically heating magnesium. So there is magnesium inside this crucible, which is being strongly heated, and it was heated for several minutes. During the heating, the crucible lid was lifted and replaced several times. The magnesium was converted into magnesium oxide. So, what the reaction that's actually taking place is that magnesium is reacting with oxygen, and it is producing magnesium oxide. We know the formula of magnesium oxide because Mg over here is 2 plus and O is 2 minus, so it's going to be MgO. This is not a balanced equation, so there would be two magnesiums and two magnesium oxide, but we never needed the equation for in the first place. Uh, B1 of the question, BI of the question states, why was it necessary for a lid to be placed on the crucible during heating? Now, it's very important to place a lid on top of the crucible so that during heating, particles of magnesium uh, they don't fall out of the crucible, because remember, when you're heating substances, they hiss and they crack, and there might be steam and or some liquid or some little amount of water that might be present, and if that evaporates, things hiss and spit, which is why they might fall out of the container. So why was it necessary for a lid to be placed on the crucible during heating? So that substance or substances, which in this case is magnesium, they don't fall out, because if they fall out of the container, then the mass would be it is going to be different. The next part is, why was the lid lifted during heating? Why do you need to lift the lid? That's important because you're reacting it with oxygen. Now it's very important, if you're reacting it with oxygen, uh, air needs to enter. There has to be a space available so that air is capable of coming in. So that is why the lid was lifted. So let's go back. Why was the lid lifted? So that oxygen gas can enter. The next part of the question is, describe the appearance of magnesium. Now, magnesium is a grayish shiny metal. The appearance of magnesium oxide, remember ionic compounds of group 1 and group 2 substances, they're always white in color. So transition metals have colored compounds. So it's going to be a white solid. So that's part C of the question. Let's move to the next part of the question, which is that after cooling, the crucible was weighed and it was then reheated, cooled, and reweighed. The final mass of the crucible plus magnesium oxide is given. So it's 13.32 grams. The question is, why was the crucible reheated? The reason it was reheated over and over again was to ensure that all the magnesium had reacted. Now that is very important. You have to ensure that all the magnesium has reacted because, which is why it's reheated over and over again and reweighed. Because as long as magnesium keeps reacting with oxygen, the mass of magnesium would keep changing because it would turn into magnesium oxide. Its mass would increase. Once all the last atoms of magnesium have reacted with oxygen, then the mass would stop increasing because there's no more oxygen getting added. So which is why you constantly reweight, and once the mass stops, it's known as heating till constant mass. Once the mass stops changing, that is when you know that the reaction has stopped. Anyways, you have to calculate the mass of magnesium oxide. Now this is the magnesium oxide with the crucible, so I need to subtract the mass of the crucible from this. Now the crucible was given previously in the previous part. If you go back and have a look, the mass of the crucible was provided over here. It was given as 12.72 grams. So I'm going to use that and I'm going to subtract that. So mass of the crucible was 12.72 grams. So if I subtract that, it's going to be 13.32. And I'm going to subtract 12.72 from it, and I get 0.60 grams. That's the mass of magnesium oxide. And now you're being asked to calculate the mass of oxygen that reacted with the magnesium. Now, for that, previously we have already found out that was magnesium was already found out. Magnesium was 0.36 grams. So that was 0.36 grams. The mass of magnesium oxide has now been found out. It's coming out to be 0.60 grams. Now that indicates that there is a difference, which means that oxygen has been added. You have the mass of magnesium, you have the mass of magnesium oxide. So the increase in mass is because of the extra oxygen that has been added. So it's going to be 0.36, 0.6. What's the difference? The difference is 0.24 grams. That's You're going to show your working. It's going to be 0.60 grams, and you're going to subtract 0.36 grams from it. The next part is you need to find the formula of magnesium oxide, and you're given the AR of both substances. Uh, Now magnesium's mass has already been found out. It's calculated as 0.36 grams as shown above. The mass of oxygen is given as 0.24 grams. So you know the mass of each substance in the formula. What you're going to do is you're going to try and find the empirical formula. How do you find the empirical formula? You find moles first. You divide it by the AR, which over here is 24, and over here the AR is oxygen is 16. And if you do that, 36 divided by 24. So 36 divided by 24 comes out to be 1.5, and 24 divided by 16, 0.24 divided by 16. Actually, let me correct this. It's 0.36 divided by 24. It comes out to be 0.015. So it comes out to be 0.015, and this also comes out to be 0.015. The next part in finding the formula is you divide by the simplest ratio, the smallest number, in this case of 0.015, and the whole number ratio comes out to be 1:1, which means that in the formula there's going to be one magnesium and there's going to be just one oxygen. So the formula that you're going to write over here is, after showing the working, is MgO. So there's one Mg and there is exactly one oxygen. Let's move to the next part of the question. Question number two. Question number two is related to electrolysis. A student electrolyzed molten lead to bromide and dilute sulfuric acid in the apparatus shown below. What was produced at the electrodes A, B, C, and D? So it's a question of electrolysis, and we have to figure that out. Now, the first, I'm going to look at the left-hand electrode. Uh, or left-hand electrolysis over here. This is molten lead to bromide, which means the solution only has two ions. One is lead 2 plus. The lead 2 plus ion is, so the lead 2 plus ion is going to get attracted to the negative electrode. This is the negative electrode. This is the cathode. And the other one is Br minus 1. Now, the Br minus 1 electrode is going to go to the positive electrode. Now, what was produced? Remember, the negative electrode is the one where electrons are being pushed towards the ion. So the negative electrode will attract the positive ion, and it's going to be sending electrons. So the reaction that's going to happen over here is it's going to be Pb2 plus, and it would end up gaining two electrons, and it would form lead. So at B, you're getting lead, or you can simply write it in words as well. You're getting lead. What's going to happen at the other electrode, Br minus 1? At the positive electrode, the anode oxidation happens. The battery is pulling electrons away. So anything that reaches this side is going to be the one that's going to be losing electrons. So the reaction that would happen is that Br minus 1 would end up losing electrons, but since it's diatomic, so there would be two Br minus 1, they would end up losing two electrons to form Br2 molecules. So A is going to be Br2. So bromine would be produced. The other part is a dilute solution. So it's aqueous, so it has a lot more ions. Sulfuric acid has H plus one, which is going to go to the negative electrode, which is shown over here. And sulfuric acid also has SO4 2 minus ions. There would be two more ions that would come from the from water because it's dilute. So whenever you have a dilute solution, two ions come from water. One is H plus one, and the other one is OH minus one. So in total, you're having let me just read a few comments. Definitely I can do some papers related to AS, and I'll definitely start doing papers related to AS as well as a live class. Make sure to subscribe to the channel as well, and make sure that you if you want to attend regular classes as well, you can sign up at our website. Okay, now so you have these ions. Now at the negative side over here, the battery is sending in electrons. So electrons are coming in, and somebody has to gain those electrons, and there is no other option apart from H plus 1 ions. It's H plus 1 ions that are going to gain electrons. And H plus 1 is diatomic as well, so there should be two H plus 1 ions that they should be gaining two electrons to form H2 gas molecules. So at D, you're going to get hydrogen gas. H2 gas is going to be formed. And what's going to happen over here at the positive anode? Now, at the positive anode, there are two options. I mean, battery has to pull electrons. Okay, so you just let me adjust that. Now, at the positive electrode, the battery has to pull electrons. So this is, you have two ions. OH minus one is so for minus two. If you remember the series over here at anode, you would realize that it's OH minus one that always ends up losing electrons, and the equation for that is that it's basically four OH minus one ions losing four electrons to form two H2O and one oxygen gas molecule. So the products that are formed over here when OH ions they lose electrons is uh, so the products are oxygen gas, and you can also add in water that is also going to be produced. The next question is part B. What if anything happened to the brightness of the lamp when the following changes were made? Water was added to the dilute sulfuric acid. Now, water, if you add water, the solution would become more dilute, which means, what does dilute mean? Dilute means that if there's less H plus one and there's a 4 minus 2 ions, then there would be a less, the transfer of electrons is going to be even lesser. So, solution becomes dilute. Then there would be fewer ions, there would be more water. So, if the solution becomes dilute, okay, so if the solution becomes dilute, that would indicate that there are fewer ions, so the brightness would decrease because there would be less charge carrying, there would be more water. So brightness of the lamp is going to decrease. The next part is the heating was stopped and the apparatus was left to cool. So if you stop the heating, then this lead to bromide would not be molten and the ions would not be able to move around, and they wouldn't be able to go to cathode or to anode to gain or lose electrons. So the transfer of electrons would stop. So you want the ions to be mobile. Without mobile ions, so there would be no free moving ions in lead bromide, and so no free moving ions in lead bromide, and electricity conduction would stop. So electricity conduction is going to stop. The next part of the question is question number three. A student recorded the results of four experiments with ethanol, which result was not correct. On reaction with acidified potassium dichromate 6, the color of the solution changed from orange to green. Now, this is correct. Remember, let's also have a brief description. What is ethanol? Eth means two carbon atoms, all means there's going to be an OH, and it's going to have hydrogens. So this over here is an ethanol molecule. Ethanol molecule gets oxidized with potassium. This one over here, potassium dichromate 6, and it gets oxidized to a carboxylic acid. The OH changes into a carboxylic acid group. The rest of the molecule remains the same. So the left side remains the same. It's the right side, the alcohol side, that changes into a carboxylic acid. So that is true. The next statement is a fact. Ethanol is soluble in water. It's very soluble in water. On combustion, a gas is produced, which now this is incorrect. Now a gas that pops in a flame is hydrogen gas. Now remember, whenever a hydrocarbon burns with oxygen, it ends up producing two things. One is carbon dioxide, and the other thing is H2O. So these gases are produced, not hydrogen gas, which is why option C is going to be the correct answer because that's the wrong answer. And alcohols and carboxylic acids, they do form esters. So the fourth option is related to esters, so that is also correct. We can actually make that ester just for revision. If I they're trying to make an ester between ethanol, which is this one, and ethanoic acid, which is a carboxylic acid. So it's this molecule over here. The end result would be that the H and the OH are going to be lost, and the two molecules, so these things over here, they're going to be lost. And the end result would be that the molecules are going to combine. So it's C with an O left, and the rest are all the hydrogen atoms. So the H at the end is lost, this H over here. And on the other side, you have C double bond O and CH3, and they're going to link up, and this is going to be your ester, which is ethyl ethanoate. Remember, esters are named in two parts. One part, this side, there are two carbon atoms, so that's eth. The other side is also eth. This side, the carboxylic acid side is O8, and the other side is the alcohol side, and that changes into ethyl. The next part of the question is apparatus shown in the diagram was used to compare the rate of the reaction, the rate of diffusion of a gas with the rate of diffusion of air. Now, a beaker containing the gas was placed over the porous spot for which the following gases did bubbles emerge at Y. Now, bubbles emerging at Y, what does that indicate? That indicates only one thing. That indicates that the only way bubbles of a gas are going to emerge at Y is that there's gas coming in through this pipe and it's coming out at the other end. Now that's only possible is that if I mean what is diffusion? Diffusion is that air is going to diffuse out of the porous spot, but at the same time the gas that's outside is going to try and diffuse inside the porous spot. Now the outside gas has to be lighter so that more gas enters the porous spot than leaves the porous spot. If it's lighter, then it's going to push the other gas molecules and bubbles would emerge from the other side. So there's air leaving the porous spot and there's air or some other gas that's entering the porous spot. You want the gas that's entering the porous spot to enter at a faster rate. You want that part to speed up. More gas needs to enter. And so it has to be lighter than air because the lighter the gas, the faster it is. Now, what is air? Air, remember, has an average MR of 29 because air is 78% is nitrogen and 21% is oxygen. So it's the average of 28, which is nitrogen, and the average of oxygen, which is 32. When you take the average, you get something between 29. So 29 is the approximate average MR of a gas. So it has to be less than 29. So the one that I can see over here quickly is hydrogen, which is going to be a very fast gas. So it's going to diffuse into the porous spot very, very quickly. So lots of hydrogen gas would be diffusing into the porous spot at a faster rate. So there's only one outlet for the gas, and that is going to be this outlet over here. Let's move to the next part of the question. Now, the next part of the question is the diagram shows which was prepared using spots of 5 different inks. Uh, what is the total number of different dyes present in the 5 inks? Different dyes. So as you can see, dyes that travel the same distance are basically the same dye. So these 3 dyes, if I can mark them, these 3 dyes over here, they're basically the same dye. These 2 dyes are traveling the same distance, so they are also the same dye. These 4 dyes are the same dye, and these. So it's basically in total that's 1, that's 2, that's 3, and 4. The 4 different dyes in in this chromatogram. Next part of the question is some metals react with dilute hydrochloric acid to give hydrogen, which the following metals will not react with. Now, the ones that will not react are the ones that are unreactive. Now, if you remember the reactivity series, copper is really low in the reactivity series. It's K, Na, C, Mg, Z, and Fe. So all the rest are very reactive. Copper is right at the bottom. It's with high. It's with it's next to silver and gold. So it's a very unreactive metal. You make copper wires out of copper, mainly because copper is so unreactive that if you build a house and it has copper wiring, then you're pretty sure that the wires and would last, and your wires would not break down or they wouldn't rust. So copper is extremely unreactive. Let's move to the next part of the question, which is they put a condenser and they've added. What's the purpose? The question is, what's the purpose of this condenser over here? Now, this is known as a reflux. So, what is a reflux? You're basically trying to, in this question, all of this experiment is not important, but what they're doing is they're heating ethanol with potassium dichromate 6, which is an oxidizing agent, so that it gets oxidized eventually into a carboxylic acid. Now, ethanol is a very volatile substance, which means that if you heat it a little bit, it's going to evaporate and change into gas. So you can see these gas molecules appearing. Now you want ethanol to react with potassium dichromate 6, but if there's nothing on top, most of the ethanol would simply evaporate and it would simply disappear into the atmosphere. So you don't want that to happen. So the purpose of the condenser is that if these ethanol particles they travel up, the condenser cools them down and they fall back into the container, and they then have no option other than to react with potassium dichromate 6. So you don't want ethanol to evaporate, so you put a condenser on top. You can't put a lid on top because that would be dangerous. Reason it's going to be dangerous is because gases expand when you heat them. So the whole thing could explode. So you can't build pressure into it. That would be ideal as well, but that would build a lot of pressure. This is a glass container, so it would break very very easily if a lot of pressure builds on in it. So you allow the ethanol vapors to escape, but they enter the condenser where they cool down and they fall back into the flask. So in this way, the ethanol doesn't escape, and it has no option other than to react with potassium dichromate 6. So the question, part C would be the correct answer for this, to prevent escape from the of the unreacted alcohol. Let's move to the next part of the question, which is now this question is related to titration. A student was given a bottle containing small piece of scrap iron. He was asked to find the purity of this sample of iron. A small quantity of the iron was placed in a previously weighed container, which was then reweighed. So there's iron in the container, and you're being asked to figure out the purity of this iron. First thing, find the mass of the iron. Calculate the mass of the iron. We'll do that quickly. We need a calculator for that. Let's open our calculators. It's going to be 6.16, and I'm going to subtract 4.72 from it, and I'm going to get 1.44 grams. So the first thing, that's the mass of iron that we are using, and this is a titration question. We want to figure out the purity. Now this is 1.44 is not the mass of the iron because there are impurities in it as well. So we need to find out what is the mass of iron. Now the question then stated that this 1.44 grams was placed in a flask and added to sulfuric acid was added, and it was completely dissolved. Now, and he's also told us that Fe2 plus ions were produced. So now you have a flask. Where did he put it? He put it. The flask was warmed and the iron reacted with it. So it's basically, I'm going to write down the reaction Fe plus H2SO4. So it's going to produce FeSO4 plus H2 gas. Now, name the gas. It's a hydrogen gas. That's the name of the gas. Give a test for this gas. Burns with a okay. So it burns with a pop sound. State the equation for the reaction. We have already written that equation. Anyways, so 1.44 grams of iron has been dissolved and it has formed FeSO4. Now, when all the iron had reacted, the solution was cool and made up to a 250 cm cube solution. So, in a graduated flask. So, let's assume this is the graduated flask. It has FeSO4 and it is 250 cm cube. And he has named this as S. that the iron had reacted and 250 cm cube solution was made and put in a graduated flask. How much iron was added? Impure iron, 1.44 grams of impure Fe. And all the iron in it has been dissolved and turned into FeSO4, and it's a 250 cm cube solution. What's the next part? A pipette transfers 25 cm cube of Hess into a conical flask, so that's what we're going to do. Let's make a conical flask, and 25 cm cube is added into this. Now, this conical flask basically has Fe2 plus, or we can say it has FeSO4, but only 25 cm cube. Remember, the original solution was 250 cm cube.